Lesson 26, Transformations. So a transformation changes position. So we're going to go over three different types of transformations first, and the first one is reflection. A reflection is like a mirror image. So it's reflecting a figure. In parentheses, just put mirror. Or flipping it over a certain line. So if you can think of the word flip, or if it looks like the figure's been flipped, then it is called a reflection. So for example, we want to reflect the triangle ABC in the y-axis. So the point A is -2, 1, B is -6, 1, and C is -2, 4. So in order to reflect it, we can graph these points . So I did -8 on the x-axis and up 5 on the y. Then I'm going to go over 8 in the positive. So -2, 1, we go to the left 2 and up 1. That's going to be A. -6, 1 will be B. And -2 and up 4 will be C. So here's our triangle, and we're going to reflect it in the y-axis. That means we're just going to flip it right over the y-axis. It looks as if we're folding it right along the y. So this is going to come, if you look at A, it's 2 units to the left of the y-axis, so we want to go 2 units to the right, and we want to leave it the same distance up and down. So this is going to be A prime, and C prime is just going to be up 4 and straight up from A prime. So we have C prime. B prime is going to go over to 6 and up 1. So a lot of times they'll ask you to do the transformation and then list the points. So A prime's point was at 2, 1. B prime was at 6, 1, and C prime is at 2, 4. Notice that if you look at the original triangle points and the reflection of that triangle, the y values stayed the same and the x values were the opposites. So that always happens when you do a reflection. The x over the, if you do a reflection in the y-axis, it happens that way. The next transformation we're going to go over is called a rotation. A rotation is just turning a figure about a point. So if you think of rotation, you might think of a turn, and if it looks like the figure's being turned, then it is a rotation. So for example, we're going to rotate triangle A prime, B prime, C prime above, so the one we just drew up here, 90 degrees clockwise around point A prime. If it just says to rotate and gives the degrees but doesn't say clockwise, it always means counterclockwise, always. So we're going to take our look at our picture up above. What I want you to do is just turn your entire notebook 90 degrees clockwise. So we're going to do this. I'm going to do it here on the video. So I'm going to turn it 90 degrees, which is going to look just like this. So if I look and think of this as the positive x-axis and this as the negative, oh no, that's not going to work because that's turning it about the origin. So let's come back here. We'll look at this. We're actually turning it right about point A. So the whole thing is just going to turn 90 degrees. So the B is going to come straight down from A instead of across to the right. It's going to come straight down. So my A prime is actually going to stay in the same spot. So it's going to be at 2, 1, and that's going to be called a double prime because now we're moving A prime, so we're going to add an extra prime there. If you notice, B is 1, 2, 3, 4 spaces to the right, so I want to go 4 spaces down because 90 degrees would take it straight down instead of to the right. So I'm going to go 4 spaces down, so 1 is at the 0, 2, 3, 4, down will be at the -3. And that will be B double prime. Now C is going straight up, so we need to move it straight to the right because that would be 90 degrees from where it is now. So it is 1, 2, 3 up, so I want to go 3 to the right. And that becomes my C double prime. So my points are A double prime is 2, 1, B double prime was 2, -3, and C double prime is 5, 1. The next transformation is called a translation. So a translation is sliding a figure in one direction without rotating the figure. So if you see a slide, you know that it's called a translation. So we want to translate, here's our example, triangle ABC, that's from our very first problem above, and we're going to do it along the vector 2, -3. That means every x value we're going to go 2 to the right, and then we're going to go down on the y value 3 units. So our original figure up above, A, is -2, 1. So we're going to go to the right 2. Here, let me draw our, there we go. We have our coordinate plane. So we're at 2, no, we're at, where was our A? -2, 1. So we go to the left 2 and up 1. Then we want to go to the right 2, which puts us on the y-axis, and we want to go down 3. 1, uh-oh, I forgot to draw my negatives. So we're at 2, 1, we go to the right 2, down 3. 1, 2, 3. And that's our A triple prime. And then our B was -6, 1 from up above, so we come over -6 and up 1. We want to go to the right 2 and down 3. So that's our B triple prime. And then C was at -2, 4. So we want to go to the right 2, which puts us on the y-axis, and down 3. So that's our C triple prime. Then we list our points. A triple prime ended up at 0, -2. B triple prime ended up at -4, -2. And C triple prime ended up at 0, 1. Okay, I'm going to turn the page. These 3 transformations, reflection, rotation, and translation, are all called isometries or congruence transformations. So you're going to write isometry or congruence transformations. So in isometry and congruence transformation, the size and shape stays the same. They will not change. So those were, again, reflection, rotation, and translation. Another type of transformation that we have is called a dilation. Now, a dilation by definition means that it can get bigger or get smaller. So if it gets bigger, we call that an enlargement, or we just enlarge the figure, and that's when it gets bigger. A reduction is if the figure gets smaller. So when we are making it bigger or smaller, we are using what's called a scale factor. That just means we are multiplying each side length by a scale factor. So we're going to do an example, say rectangle, here we'll call this an example, ABCD is 2 centimeters by 1 centimeter. So, and rectangle A prime, B prime, C prime is 4 centimeters by 2 centimeters. So let's draw a picture of rectangle ABCD. We have AB is 2 centimeters, AD is 1 centimeter. And then we have triangle A prime, B prime, C prime, D prime. And A prime, B prime is going to be 4 centimeters, and A prime, D prime will be 2 centimeters. So rectangle, if we just look at rectangle ABCD, the perimeter is 2 plus 1 plus 2 plus 1 is 6 centimeters. The area will be 2 centimeters times 1 centimeter, which is 2 centimeters squared. If we look at rectangle A prime, C prime, A prime, B prime, C prime, D prime, the perimeter will be 4 plus 2 plus 4 plus 2, which is 12 centimeters, and the area will be 4 times 2 centimeters squared, 8 centimeters squared. So if you notice the scale factor, in this case, of dilation is 2 times. So the scale factor, we went from 2 to 4 and from 1 to 2. We had to multiply each side by 2. If we wanted to look at the scale factor of the perimeter, that's also 2 times. So whatever the scale factor is, notice that we had to multiply perimeter by 2. So they're 2 times. The scale factor of the area is actually 2 squared times, or 4 times. So if we took our area in the first one, which was 2, we multiply it by 4, and the new area will be 8. So we just have to remember the scale factor of the area will be the scale factor squared. So the original scale factor squared. That's the end of the lesson.